Hello there, and welcome to the Sleepy Library. Tonight, we're going to explore one of the most calming and mind-soothing questions humans have ever asked about our cosmos. Does space end? Where does the universe go, if it goes anywhere at all? These are questions that have puzzled minds for thousands of years, questions that whisper quietly in the darkness, inviting us to wonder without urgency, to drift among the stars in thought. So settle in, get comfortable, and let your mind wander gently through the vastness of space. There is no rush, no deadlines, just quiet curiosity floating on a sea of stars. We'll take this journey slowly, one peaceful thought at a time, exploring what scientists have discovered and what remains wonderfully mysterious about the edges of everything. Let's begin with a simple question that turns out to be beautifully complex. When we ask if space ends, what do we really mean by end? This question itself opens like a flower with many petals, each one revealing a different way of thinking about boundaries and beginnings. The word end could mean a physical boundary, like a wall at the edge of existence where space simply stops. Imagine traveling through the cosmos in a spaceship, going farther and farther, until suddenly you encounter something like a cosmic fence or barrier. You reach out and touch it, and beyond it, there is nothing. Not empty space, but truly nothing at all. No space, no time, no possibility of going further. This is one way to think about an ending. But there is another possibility, one that feels almost magical in its strangeness. Space could be curved in such a way that it has no edge at all, even though it contains a limited amount of volume. Think about walking on Earth. You can walk in any direction for as long as you like, and you will never hit a wall or fall off an edge. Yet Earth is not infinite. It's a sphere with a finite surface area. You could walk all the way around it and return to where you started, never encountering a boundary, yet never walking through infinite space. The universe might work the same way, except in 3 dimensions instead of 2. Space could curve back on itself in a shape that has no edges, but is still finite in size. This idea feels gentle and complete, like a perfect circle drawn in the dark. No beginning, no end. Just a continuous loop of existence. To understand these possibilities, scientists look at the shape of the universe, and when they talk about shape, they mean something specific and mathematical. They're talking about geometry, about how space itself bends and curves in response to all the matter and energy it contains. There are 3 main shapes that the universe could have, and each one tells a different story about endings and infinities. These shapes are called flat, closed, and open. Let's explore each one gently, taking our time to understand what they mean. Imagine a perfectly flat sheet of paper extending in all directions. This represents a flat universe. In this kind of space, if you draw a triangle, the angles inside will add up to exactly 180 degrees, just like you learned in school. Parallel lines will never meet, no matter how far you extend them. This is the geometry we're most familiar with, the one that feels intuitive and comfortable. A flat universe could go on forever. It might be truly infinite, stretching endlessly in every direction without boundary or edge. In such a universe, space would have no end, because there would always be more space beyond wherever you happen to be. No matter how far you traveled, there would always be further to go, always more universe to explore. But here's something interesting and soothing in its subtlety. A flat universe doesn't have to be infinite. It could also be shaped like a torus, which is the mathematical name for a donut shape. Imagine space wrapping around itself in multiple directions, like a 3-dimensional video game where going off one edge brings you back from the opposite edge. In this case, the universe would be flat in its local geometry, but finite in its total volume. You could travel in a straight line forever, and eventually return to where you started, never hitting a wall, but never traveling through infinite space either. Now let's think about a closed universe. This is a universe with positive curvature, where space curves back on itself like the surface of a sphere. In this kind of universe, if you drew a very large triangle in space, the angles would add up to more than 180 degrees. Parallel lines, if extended far enough, would eventually meet and cross. A closed universe is finite in size. It contains a specific amount of space, a specific volume, yet it has no boundary or edge. Just like you can travel around Earth's surface without ever falling off or hitting a wall, you could travel through a closed universe forever without encountering an end. You would simply curve through space, eventually returning to your starting point if you traveled far enough. This possibility is peaceful to contemplate. A universe that is complete and whole, with no rough edges or abrupt endings. Everything contained within itself, like a perfect sphere floating in the void. If you sent light out in a straight line through such a universe, it might eventually circle all the way around and return to you from the opposite direction. The third possibility is an open universe, one with negative curvature. This kind of space curves in the opposite way from a closed universe. Instead of curving like a sphere, it curves like a saddle. If you drew a triangle in this space, its angles would add up to less than 180 degrees. Parallel lines would diverge, growing farther apart as they extended into the distance. An open universe would most likely be infinite. It would extend forever, always providing more space, always offering new regions to explore. There would be no edge, no boundary, just endless space, curving gently in a particular mathematical way. Now, you might be wondering, how do scientists figure out which of these shapes describes our actual universe? It's a beautiful question with a beautiful answer that involves looking at the oldest light in the cosmos. Shortly after the Big Bang, when the universe was very young, it was filled with hot, glowing plasma. As it expanded and cooled, this plasma eventually became transparent, releasing light that has been traveling through space ever since. We call this light the cosmic microwave background, or CMB for short. It's like a baby picture of the universe, showing us what everything looked like when it was only about 380,000 years old. Scientists have built special instruments in space that can measure this ancient light with incredible precision. Two of the most famous are the Wilkinson Microwave Anisotropy Probe and the European Planck satellite. These spacecraft measured tiny temperature variations in the cosmic microwave background, variations that tell us about the shape and structure of space itself. The data from these missions revealed something remarkable. The universe appears to be very flat. Not perfectly flat, but so close to flat that current instruments cannot detect any curvature at all. The measurements suggest that if there is any curve to space, it's so slight that it would take distances far beyond what we can observe to notice it. This finding suggests, though doesn't prove, that our universe might be infinite. A perfectly flat universe with the simplest possible shape would extend forever in all directions. But remember, flat doesn't necessarily mean infinite. The universe could still be flat and finite if it has a more complex shape, like that torus we mentioned earlier. Let's talk for a moment about what an infinite universe would really mean. Imagine space going on forever, with no edge anywhere. Galaxy after galaxy after galaxy, extending into distances so vast they make our observable universe seem like a tiny bubble in an endless ocean. In such an infinite universe, something peculiar and rather dreamlike would happen. Because there are only so many ways that matter can arrange itself, patterns would eventually repeat. Given infinite space and infinite matter, every possible configuration of atoms would occur not just once, but infinitely many times. This means that somewhere, unimaginably far away, there might be another planet exactly like Earth, another person exactly like you, reading these exact words at this exact moment. In fact, there would be infinitely many copies scattered throughout the infinite expanse. Some copies would be perfect duplicates, others would be almost the same, but with tiny differences. One might have had different weather yesterday, another might have chosen a different breakfast. This isn't science fiction. It's a genuine mathematical consequence of combining infinity with the finite number of ways particles can be arranged. The distance to these duplicates would be incomprehensibly vast, far beyond anything we could ever observe or reach. But in an infinite universe, they would exist with mathematical certainty. Let's shift our thoughts now to the possibility of a finite universe. If space is finite, if it contains only a limited volume, what does that mean? Does it mean there are walls at the edge? No. And this is one of the most comforting insights from modern physics. A finite universe doesn't need walls or boundaries. It doesn't need an edge where you stop and can't go further. Remember the surface of Earth, how it's finite yet boundless. The universe could be the same way, just with an extra dimension. In a finite universe, space would curve back on itself in some way. You could travel in any direction forever without hitting a barrier. You would simply move through the existing space, perhaps eventually returning to your starting point. Like an ant walking around a beach ball, you would traverse a limited area without ever encountering an edge. This finite space would contain everything. All the galaxies, all the stars, all the matter and energy that exists. It would be complete, a closed system with a specific volume, yet without boundaries. The concept challenges our intuitions, because we're used to thinking that anything finite must have edges. But in the curved geometry of space, finite can coexist with boundless. Now let's talk about something important that often confuses people. When we look out into space with our telescopes, we can only see so far. There is a horizon beyond which we cannot observe anything. Not because there's nothing there, but because light from those distant regions hasn't had enough time to reach us yet. The universe is about 13.8 billion years old. Light has been traveling toward us for all that time. But because space itself has been expanding, the most distant objects we can see are now about 46 billion light-years away in any direction. This creates a sphere around us, a cosmic horizon, that defines what we call the observable universe. This horizon is not the edge of the universe itself. It's just the edge of what we can see from our particular location at this particular time in cosmic history. Other beings in distant galaxies would have their own observable horizons, centered on their locations. Some of what they can see, we cannot, and some of what we can see, they cannot. Every year, as light from slightly more distant regions has time to reach us, our observable universe grows a bit larger. We see new, older light arriving from farther away. Our cosmic horizon expands slowly outward as the universe ages and more light has time to travel to us. But beyond our horizon, space continues. How far it continues, we don't know. It might continue forever, or it might curve back on itself at distances far beyond what we can observe. Our horizon moves with us, like the horizon on Earth's surface, always maintaining the same distance, always revealing slightly new territory as we move forward through time. This observable horizon is not a wall. Nothing prevents things from existing beyond it. It's simply a limit on what we can see, a consequence of the finite age of the universe and the finite speed of light. Somewhere out there, far beyond our view, there might be other galaxies that we will never be able to see because they're receding from us faster than light can travel toward us through expanding space. Let's drift now into a related idea, one that feels almost like a dream within a dream. If our universe is finite, it might be just one of many universes floating in a larger structure called a multiverse. The theory of cosmic inflation, which explains many features of our universe, suggests that different regions of a larger space might have inflated in different ways, creating separate pocket universes. Each pocket would be its own universe, with its own physical laws and constants, separated from the others by vast distances or unreachable boundaries. In this picture, our universe would be one bubble in an infinite foam of universes. Some of these other universes might be similar to ours. Others might be drastically different, with different numbers of dimensions, different types of particles, different forces of nature. We would be unable to visit them or observe them because they're fundamentally disconnected from our space. This multiverse idea is speculative. It emerges naturally from certain theories about the early universe, but we have no direct evidence for it. It remains a possibility, a perhaps, a maybe, painted in the colors of mathematics and theoretical physics. But it's a soothing thought in its way, suggesting that if our universe is finite, it might be part of something larger, something that continues beyond our cosmic boundaries. Now let's imagine, just for a moment, what it would be like to reach the end of space. If such an end existed, would you hit a wall? What would that wall be made of? What would be beyond it? These questions lead us into deep philosophical territory. A wall implies something on the other side, even if it's just empty space. But if space ends, there wouldn't be another side. There wouldn't be empty space beyond. There would be no beyond at all. No distance, no direction, no possibility of going further. It's a concept that slides away from our grasp like water through fingers, because all of our intuitions are built on the idea that if you can imagine pointing in a direction, there must be something there to point toward. Perhaps instead of hitting a wall, you would curve back to where you started, like traveling around a sphere. You would think you were going straight, traveling in one direction through space, but the curvature would gradually turn you until eventually you arrived back at your origin. You might not even notice the turning, because everything around you would be curving the same way. There would be no sense of making a turn, just the gradual realization that you'd returned home. Or perhaps space would simply stretch faster than you could travel through it. As you moved forward, trying to reach an edge, new space would expand in front of you, always staying ahead of your progress. The edge would recede faster than you could approach it, like trying to reach the end of a rainbow. You would travel forever without ever arriving at the boundary you sought. The truth is, we don't know what would happen at the edge of space, assuming such an edge exists, because we have no evidence that there is an edge. All our observations suggest either infinite space or finite space that curves back on itself without boundaries. Both possibilities leave us without walls to encounter, without edges to cross, just endless continuity in one form or another. Let's think for a while about the measurements scientists use to determine the universe's shape. They look at something called the density parameter, which compares the actual density of matter and energy in the universe to a critical density that would make space perfectly flat. If the universe contains exactly the critical density, it would be flat. If it contains more than the critical density, it would be closed and finite, curving back on itself like a sphere. If it contains less than the critical density, it would be open and most likely infinite, curving like a saddle. The measurements are remarkably close to the critical density. The latest data suggests that the density parameter is very close to 1, which would mean a flat universe. But the measurements have some uncertainty. The true value could be slightly above or below 1, which would change the shape of space in ways we haven't yet detected. This uncertainty means we can't say for certain whether the universe is infinite or finite. The evidence leans toward flat or nearly flat, which suggests infinite. But it doesn't rule out other possibilities. Space could be very slightly curved in ways our current instruments can't measure. Or it could have a complex topology that makes it finite even if it's flat. Consider the various forms a flat universe could take. The simplest is an infinite plane, extending forever in all directions. But there are also finite flat shapes. The torus we mentioned is one. There are also other shapes, more complex, with strange names like the Klein bottle or the three-dimensional manifolds discovered by mathematicians. Each of these would be flat in its local geometry, but finite in its total volume. To detect these exotic topologies, scientists look for specific patterns in the cosmic microwave background. If space wrapped around itself in some way, we might see repeated patterns in the ancient light, like seeing multiple images of the same distant galaxy in different directions. So far, such patterns haven't been found, but the search continues with ever more precise instruments. Let's drift into thinking about dimensions for a moment. We experience 3 dimensions of space, the ones we call length, width, and height. But to make sense of a finite yet boundless universe, scientists often use mathematics that involves a 4th spatial dimension. Don't worry, this 4th dimension doesn't exist in the real world. It's a mathematical tool, a way of visualizing how 3-dimensional space could curve through a higher dimension and close back on itself. Think about how a 2-dimensional surface, like a sheet of paper, could be curved through our 3-dimensional space to form a sphere. In the same way, our 3-dimensional space could curve through an imagined 4th dimension to form a closed shape. This 4th dimension is not time, though time is sometimes called the 4th dimension in a different context. It's purely a mathematical construct, a way of describing curvature without having to picture impossible shapes. The curvature is real and exists in our 3-dimensional space. The 4th dimension is just a helpful tool for understanding it. When you think about space curving, remember that it's not curving into anything you could point to. It's intrinsic curvature, a property of the space itself, not a bending through some larger space. This can be hard to picture, but you can feel its truth. The geometry changes. Distances behave differently than they would in flat space. Triangles have unexpected properties. But nothing leaves the 3 dimensions we know. Now let's consider time for a moment. We've been talking about whether space ends, but what about time? Does time have an end? Does the universe have a temporal boundary as well as a possible spatial one? The Big Bang represents a beginning of sorts. It's the point beyond which we can't trace things back, the moment when our universe as we know it came into existence. But whether this represents the absolute beginning of everything, or just the beginning of this particular phase of existence, remains unknown. As for the future, that depends on the shape and contents of the universe. If the universe is open or flat and contains dark energy, as observations suggest, it will expand forever. It will grow increasingly cold and empty as galaxies move farther apart, stars exhaust their fuel, and black holes eventually evaporate into radiation. This would be a temporal ending of sorts, Not a moment when time stops, but a gradual fading into cold emptiness. If the universe were closed and contained only matter with no dark energy, it might eventually stop expanding and begin contracting. Everything would fall back together, ending in a big crunch, a final moment of infinite density and temperature. Time itself might end at such a singularity, just as it began at the Big Bang. But current observations suggest the expansion is accelerating, driven by mysterious dark energy that pushes space apart. This acceleration seems to rule out a big crunch, pointing instead toward eternal expansion. The universe would have a beginning, but no end, continuing forever into an increasingly cold and dark future. Let's think about what we mean by space itself. Space isn't just emptiness, isn't just the absence of things. According to Einstein's theory of relativity, space is a physical entity, a fabric that can bend and stretch and ripple. It's intertwined with time to form space-time, a four-dimensional structure in which all events occur. This space-time fabric is what expands when we say the universe is expanding. New space comes into existence between galaxies, stretching the distance between them. This isn't matter moving through space. It's space itself growing, carrying matter along with it. When we ask if space ends, we're asking about the extent of this fabric. Does the space-time manifold, as scientists call it, have boundaries? Does it extend infinitely, or does it curve and close back on itself? These questions probe the nature of reality at its most fundamental level. The expansion of space creates another interesting puzzle. The galaxies at the edge of our observable horizon are receding from us at speeds faster than light. This might seem to violate Einstein's rule that nothing can travel faster than light, but it doesn't. The galaxies themselves aren't moving through space faster than light. Space itself is expanding, carrying them along. There's no speed limit on how fast space can expand. This means that there are regions of space moving away from us so quickly that light from there will never reach us, no matter how long we wait. These regions are permanently beyond our cosmic horizon. Even though they exist, even though they're part of the same universe, we will never be able to see them or learn anything about them through direct observation. Let's imagine the different possibilities for how space might end, if it ends at all. In an infinite universe, there is no end. You could travel in any direction forever and always find more universe ahead of you. More galaxies, more stars, more planets, stretching on without limit. It's a humbling thought, a peaceful one in its way. No matter how far you go, there's always further. No matter how much you see, there's always more. In a closed universe, you wouldn't hit an end, but you would eventually return to your starting point. If you could travel fast enough, if you could cross the billions of light years involved, you would curve through space and come back around. Looking in one direction, you might eventually see your own galaxy from the other side. It would be like living inside a sphere, seeing the same points from multiple directions. In a universe with complex topology, you might see patterns repeating. You might look out and see what appears to be many galaxies, when in fact you're seeing the same galaxy multiple times, its light having taken different paths through spaces. Twisted geometry to reach your eyes. The universe would be smaller than it appears, with light taking circular routes through wrapped-around space. Consider the emotional response to these different possibilities. An infinite universe might feel overwhelming in its vastness, but also comforting in its endless potential. Somewhere in that infinity, anything possible would be real. A finite universe might feel cozier, more comprehensible, with everything contained in a specific knowable volume. both possibilities have their own kind of peace. The question of whether space ends has occupied human minds for thousands of years, long before we had the tools to seriously investigate it. Ancient philosophers debated whether the cosmos was finite or infinite. Some argued that infinity was impossible, that everything must have bounds. Others countered that any boundary would require something beyond it, leading to infinite regression. These philosophical arguments, beautiful as they were, couldn't settle the question. Only observation and measurement could do that. And even now, with our sophisticated instruments and precise measurements, we can't give a final answer. We can only say what seems most likely, what the evidence suggests, while acknowledging that the ultimate truth might lie forever beyond our grasp. Let's talk about what we do know with confidence. We know that the universe is vast, almost beyond imagination. We know that it's expanding, carrying galaxies away from each other. We know that space itself can curve and stretch. We know that our observable universe extends about 93 billion light-years from side to side, containing roughly 2 trillion galaxies. We know that the geometry of space is very close to flat, suggesting either infinite space or finite space with a complex topology. We know that the universe began approximately 13.8 billion years ago, in what we call the Big Bang. We know that it contains mysterious dark matter and dark energy that make up most of its mass and energy. But we don't know if space extends forever or curves back on itself. We don't know if our universe is alone or one of many. We don't know what lies beyond our cosmic horizon. We don't know if the word beyond even makes sense in this context. These unknowns aren't failures of science. They're reminders of how much mystery remains, how many questions still float unanswered in the darkness between the stars. Think about the nature of boundaries themselves. In our everyday experience, boundaries are common and clear. This room has walls. This paper has edges. This land has borders. But the universe might not follow these familiar rules. Its boundary, if it has one, might be of a completely different nature than anything we encounter in daily life. Or perhaps the question itself is flawed. Perhaps asking, "Does space end?" is like asking, "What's north of the North Pole?" At the North Pole, the concept of north breaks down. Can't go further north because you're already at the northernmost point. Similarly, perhaps at the scale of the entire universe, the concept of ending breaks down into something that doesn't match our intuitions. The mathematics allows for both possibilities, infinite and finite. The physics doesn't require either one. Observation can't distinguish between a very large, finite universe and a truly infinite one, because we can only see to our horizon. We're like people living on a vast planet, trying to determine if the surface is infinite or just extremely large, by examining the visible portion around us. Let's rest for a moment in this uncertainty. Not knowing can be peaceful. The question remains open, inviting wonder rather than demanding answers. Space might end, or it might not. Both possibilities are beautiful in their own way. Both fill the mind with quiet awe. If you find yourself awake, thinking about these cosmic questions, let your thoughts float gently among the stars. There's no need to solve these mysteries tonight. They've waited billions of years. They can wait a bit longer. The universe will continue its expansion, whether we understand it fully or not. The galaxies will spin, the stars will shine, and space will stretch into tomorrow, whether it has an end or not. Consider how remarkable it is that we can even ask these questions. For most of human history, the nature of space beyond Earth was completely unknown. Now, we can measure the curvature of space itself, detect light from the edge of the observable universe, and construct mathematical models that describe the possible shapes of all existence. This knowledge came gradually, peacefully, through careful observation and thought. Astronomers watching the night sky, physicists working with equations, engineers building telescopes and satellites, mathematicians exploring abstract geometries, each contribution adding to our understanding, each discovery opening new questions as it answered old ones. The search continues. New telescopes are being built, more powerful and precise than ever before. Satellite missions are being planned to measure the cosmic microwave background with even greater accuracy. Computer simulations explore what different universe shapes would look like. The question of whether space ends remains active, alive, pursued by curious minds around the world. But for now, for tonight, it's enough to know that the question exists. The universe holds its secrets gently, revealing them slowly over time. Whether space goes on forever or curves back on itself somewhere beyond our sight, it provides a home for everything we know. It contains all the matter, all the energy, all the light. It is the stage on which every story unfolds. Think about your place in this vast or infinite expanse. You are here, in this moment, contemplating questions that span the entire cosmos. Your thoughts can reach to the edge of the observable universe and beyond, wondering about things no eye will ever see. This ability to think about infinity, to consider the edges of everything, is itself remarkable. As you drift towards sleep, let these thoughts become softer, gentler, less concrete. The universe doesn't need your attention tonight. It will keep spinning, keep expanding, keep existing in whatever form it takes. Your task now is simply to rest, to let go of wondering, to allow sleep to come in its own time. The stars will still be there tomorrow. The questions about space's boundaries will wait patiently for another day. Right now, there is only this moment, this breath, this slow relaxation into comfort and quiet. Whether space ends or continues forever, you are safe here, in this small pocket of existence, this tiny corner of everything. Let the vastness of the universe be a backdrop for peaceful thoughts. All that space, all those galaxies, all that cosmic immensity, and here you are, a small and precious part of it all. Allowed to rest, allowed to dream, allowed to simply be without having to understand everything. The question of whether space ends isn't urgent. It doesn't require an immediate answer. It's a thought that can float away now, returning to the realm of cosmic mysteries, leaving you here in the present moment, ready for sleep. Your mind has wandered far tonight, out among the galaxies and beyond, contemplating possibilities that stretch imagination to its limits. Now, let that wandering mind come home, return to the familiar warmth of here and now, to the simple comfort of being in one place at one time without needing to think about the edges of forever. Space is large, perhaps infinitely so, but your space right now is small and contained, safe and comfortable. This bed, this room, this moment, that's all the universe you need to concern yourself with as sleep approaches. The rest can wait. The cosmos will take care of itself while you dream. Whether space ends or continues endlessly doesn't change the fact that you are here, that you exist in this present moment, that you are part of something vast and wonderful. You don't need to map all of existence to appreciate your place within it. You don't need to reach the edge of space to be at peace with the space around you. And so, as our journey through these questions comes to its own gentle end for tonight, let yourself feel the satisfaction of having contemplated something grand. You've thought about the biggest possible questions, the furthest reaches of reality, and now you can let those thoughts dissolve like stars fading in the dawn. Does space end? Maybe, maybe not. Both answers carry wonder, and for now, that's enough. The universe, in whatever form it takes, is content to keep its ultimate secrets. You can be content to rest, to sleep, to let the mysteries remain mysterious for another day. Your breathing is slowing now. Your body is releasing tension. Your thoughts are becoming less sharp, less focused, more dreamlike. This is natural. This is good. Sleep is approaching on quiet feet, ready to embrace you, ready to carry you gently through the night. Imagine floating in space, not frightened by the vastness, but cradled by it, surrounded by distant stars that burn softly like nightlights. You are not lost in this immensity. You are held by it, part of its fabric, woven into the same space-time that contains everything. Whether it ends or continues forever, you belong here. Let that sense of belonging sink deep. You are made of the same atoms that form stars and galaxies. The elements in your body were forged in ancient suns that lived and ended long before Earth formed. You are quite literally made of stardust, part of the universe examining itself, thinking about its own boundaries. What a peaceful thought. What a gentle way to consider your existence. You are not separate from the cosmos, wondering if it ends. You are the cosmos, wondering about itself. And now the cosmos, in the form of you, is preparing to rest, to sleep, to dream whatever dreams may come. The question floats away now, like a balloon released into a summer sky. Does space end? You've thought about it, considered it, given it its due attention. Now you release it back to the philosophers and scientists, the astronomers and mathematicians. They will continue the search. You can simply rest. Feel how heavy your body has become, how comfortable, how ready for sleep. Your mind has traveled far tonight, across billions of light years in thought, and now it returns home to this moment, this bed, this simple, beautiful act of letting go and allowing rest to come. The universe doesn't require your vigilance tonight. It will expand on its own, follow its own geometry, maintain its own mysterious nature without your oversight. Your job now is not to understand, but simply to be, to breathe, to rest, to allow the peacefulness of not knowing to wash over you like a gentle tide. And as you finally release these thoughts, as your mind goes quiet and still, remember this. You have done enough for today. You have thought enough, questioned enough, wondered enough. The cosmos and all its puzzles will wait for you. Right now, there is only this moment of settling into sleep, this letting go of wakefulness, this gentle surrender to rest. The stars are distant and quiet. Space, whether infinite or finite, is peaceful in its vastness. And you, here in your small corner of everything, are allowed to stop wondering, stop thinking, and simply sleep. The universe holds you gently as you drift away from waking thoughts and into dreams. Close your eyes if you haven't already. Let your breathing become even deeper, even slower. Feel the weight of your body against the bed, supported completely, needing to do nothing, hold nothing, think nothing. Just be, just rest, just sleep. The question of space's ending fades into the background now, a distant concern from a wakeful world that seems far away. There is only this darkness behind your eyelids, this calm in your body, this quiet in your mind. The universe, in all its mystery and majesty, wishes you peaceful dreams. Sleep now. The cosmos will be here tomorrow. Still vast, still mysterious, still beautiful. But tonight, you rest. Tonight, you let go. Tonight, you drift into sleep's gentle embrace, carrying with you no concerns about the edges of infinity, only the simple peace of being alive, being here, being ready to dream. The concept of space having an end connects deeply to another profound question about how our universe came to be. Let's think gently about the beginning, about the Big Bang, and how it relates to questions of boundaries and edges. About 13.8 billion years ago, everything we can see was compressed into an incredibly tiny space, smaller than a single atom. Then it began expanding, and that expansion continues today. But this beginning raises interesting questions about endings. If the universe had a beginning in time, does it follow that space must have an end? Or that it will have an end in the future? The answer is surprisingly nuanced and peaceful in its complexity. A beginning in time doesn't require an end in space. The universe could have started from a small region and expanded to become infinite. Think of it like a balloon being inflated. The rubber starts in a small ball, but as you blow air into it, the surface expands. Now imagine if the surface could expand forever, growing larger and larger without limit. That's similar to how the universe could be born, finite, and grow to become infinite. Or perhaps space was already infinite at the moment of the Big Bang, and what expanded was not the extent of space, but the density within it. In this picture, there would have been infinite space even at the beginning, but everything was compressed into infinite density everywhere. As expansion proceeded, this density spread out, creating the universe we observe. This possibility feels almost magical, an infinity contained within itself from the very start. Scientists also contemplate what they call the cosmological constant, a form of energy that seems to be pushing space apart. This dark energy, as it's sometimes called, makes up about 70% of all the energy in the universe. Its presence suggests that the expansion of space is actually accelerating, getting faster over time, rather than slowing down. If this acceleration continues forever, it has interesting implications for the fate and extent of space. Distant galaxies will recede from us ever faster. Eventually, galaxies beyond our local group will disappear beyond our cosmic horizon. Their light unable to reach us anymore, because space is expanding too quickly between us. The observable universe will actually shrink in terms of what we can see, even though space itself continues expanding. In such a future, our descendants, if they exist billions of years from now, would look out and see far fewer galaxies than we see today. Most of the universe would have accelerated away beyond their view. They might wonder, just as we do now, whether space ends somewhere beyond their horizon. And they would have even less information to work with than we have, making the question even more mysterious. Let's think about the actual measurements that tell us about space's shape. Scientists look at the cosmic microwave background and examine patterns in how the ancient light varies across the sky. These patterns depend on the geometry of space. If space is flat, the patterns have a certain size. If it's curved, the patterns would be stretched or compressed in predictable ways. The measurements show patterns that match a flat universe almost perfectly. The size of the brightest spots in the cosmic microwave background is about 1 degree across, which is exactly what you'd expect for flat space. If the universe were closed and curved like a sphere, these spots would appear larger. If it were open and saddle-shaped, they would appear smaller. but they're right at the size that suggests flatness. However, flat doesn't automatically mean infinite. This is an important distinction that brings peace through its subtlety. A flat piece of paper extends infinitely if it's a simple, infinite plane. But you can take a flat piece of paper and connect opposite edges to form a cylinder. That's still flat locally, but it's finite and wraps around. You can do even more complex connections to create shapes like a torus or other exotic geometries, all flat but all finite. So, when scientists say the universe is flat, they mean the local geometry is flat. But the global topology, the overall shape, and whether it's finite or infinite, remains uncertain. We would need to detect specific patterns in the cosmic microwave background, or in how galaxies are distributed to determine the topology. So far, no such patterns have been conclusively found, but the search continues with increasingly sensitive instruments. Let's consider the philosophical implications of these different possibilities. An infinite universe means that everything that can happen, given the laws of physics, does happen somewhere. Not just once, but infinitely many times. This includes every possible variation of your life, every choice you didn't make, every path you didn't take. Somewhere in the infinite expanse, all those alternatives are real. This idea can feel overwhelming, but it can also be comforting. It means that possibilities are truly endless, that creativity and variety are built into the structure of reality itself, that the universe is not just vast, but endlessly inventive, exploring every permutation of existence. A finite universe, on the other hand, contains a specific set of things, a definite collection of galaxies and stars. It's complete and knowable in principle, even if not in practice. There's something appealing about this too, a sense of the universe as a whole, complete entity, not dissipating into infinite variations, but containing exactly what it contains, no more, no less. Both possibilities invite different kinds of wonder. Neither is frightening when you settle into them gently. Infinity and finitude both have their own kind of peace, their own way of fitting into how we think about existence and our place in it. Now let's talk about what happens at very large distances in the universe. Astronomers have discovered that the universe doesn't just contain galaxies scattered randomly through space. Instead, galaxies arrange themselves into a cosmic web, a vast network of filaments and clusters separated by enormous voids. These structures are the largest known in the universe. Filaments of galaxies stretch for hundreds of millions of light years. Clusters contain thousands of galaxies bound together by gravity. And between them lie voids, regions nearly empty of galaxies, spanning similar vast distances. This web-like structure gives us clues about the universe's extent and nature. If we saw the structure repeating in exactly the same pattern at different locations, that might indicate the topology is more complex, that space wraps around, and we're seeing the same structures from different angles. But so far, the cosmic web appears unique in every direction, suggesting that if space does curve back on itself, it does so at scales much larger than we can currently observe. The formation of this cosmic web also tells us something about how uniform the early universe was. Tiny variations in density, present from the very beginning, grew over billions of years into the structures we see today. Gravity pulled matter together where it was slightly denser, creating galaxies and clusters, while leaving voids where matter was slightly less dense. These tiny initial variations are visible in the cosmic microwave background as subtle temperature differences. They're incredibly small, just a few parts in 100,000, but they were enough to seed all the structure we see today. This delicate balance, this fine-tuning of the initial conditions, is part of what makes the universe so fascinating to contemplate. Let's drift for a moment into thinking about what observers in other galaxies would see. If space is infinite, there could be countless civilizations spread throughout the cosmos, each with their own observable horizon. What would they see from their vantage points? They would see a universe much like ours, centered on their location. They would have their own cosmic horizon, roughly 93 billion light-years across, containing about 2 trillion galaxies. Some of what they see, we also see, but much of what they observe lies beyond our horizon, forever invisible to us. And similarly, much of what we see lies beyond their horizon. If we could somehow communicate with observers in very distant galaxies, we could share information about parts of the universe neither of us can directly observe. Combining our observations, we could build a more complete picture, seeing beyond our individual horizons. Though in practice, the distances involved and the expansion of space make such communication impossible, it's a pleasant thought to contemplate. These distant observers would also wonder about whether space ends. They would make their own measurements, study their own cosmic microwave background, and contemplate the same questions we do. The universe would present them with the same mysteries, the same beautiful uncertainty about its ultimate extent. Now let's think about time again, but from a different angle. When we look out into space, we're also looking back in time. Light takes time to travel. So when we observe distant galaxies, we're seeing them as they were long ago, when that light began its journey toward us. The most distant objects we can see appear as they were more than 13 billion years ago, when the universe was young. We see galaxies forming, stars beginning to shine, the cosmic structures just starting to take shape. Looking outward in space is like watching a movie of cosmic history, playing backwards as we go to greater distances. This means our observable universe is not just a sphere of space, but also a sphere of time. The edge of what we can see is not just distant in space, but ancient in time. As telescopes become more powerful, we see farther and therefore earlier. We approach the moment of the cosmic microwave background, the oldest light we can observe, emitted when the universe was only 380,000 years old. Beyond that epoch, the universe was opaque. The hot plasma absorbed light rather than transmitting it. So, there's a fundamental limit to how far back we can see with light. Even perfect instruments can't observe earlier times directly, because the light from that era never had a chance to travel freely through space. This temporal horizon is different from the spatial horizon we've been discussing. The spatial horizon limits where we can see because of the universe's age and expansion. The temporal horizon limits when we can see because of the physics of the early universe. Both horizons define boundaries to our knowledge, soft edges beyond which direct observation cannot reach. Yet these boundaries are not walls in the traditional sense. They're more like veils, separating what we can know from what we must infer or imagine. And with each passing year, our instruments improve, our understanding deepens, and the veils become slightly more transparent, revealing new details about the nature and extent of space. Let's consider now the role of dark matter in shaping the universe. This mysterious substance makes up about 25% of all the mass and energy in the universe. Yet, it doesn't emit, absorb, or reflect light. We know it exists only through its gravitational effects on visible matter and light. Dark matter played a crucial role in forming the large-scale structure of the universe. Its gravity helped pull normal matter together into galaxies and clusters. Without dark matter, the universe would look completely different. Galaxies might not have formed at all, or they would be much smaller and less numerous. The distribution of dark matter also affects the overall geometry of space. Its mass contributes to the total density of the universe, helping to determine whether that density exceeds, equals, or falls below the critical value that distinguishes between closed, flat, and open geometries. Current measurements suggest that when you add up all the dark matter, normal matter, and dark energy, the total comes out very close to the critical density, consistent with a flat universe. But dark matter remains mysterious. We don't know what particles it's made of. We don't know exactly how it interacts with itself, or with normal matter beyond gravity. These unknowns add to the larger mystery of the universe's nature and extent. Understanding dark matter better might help us understand whether space is truly infinite or merely very large. Think about the poetry of these cosmic substances. Dark matter, invisible yet influential, shaping everything through pure gravitational pull. Dark energy, pushing space apart, driving the acceleration of cosmic expansion. And between them, the normal matter that makes up everything we can see, less than 5% of the total, yet it's what we're made of, what forms the stars and planets, what carries light and life. These three components work together to determine the universe's fate and perhaps its extent. Their proportions could have been different. In other possible universes, if such things exist, the balance might be shifted. More dark matter might have caused everything to collapse long ago. Less dark energy might have allowed gravity to halt the expansion. But in our universe, the balance is just right to create a cosmos that's both ancient and still evolving, both vast and still observable. Let's talk about what scientists call the observable universe versus the whole universe. This distinction is crucial for understanding questions about endings. The observable universe is everything we can, in principle, see from Earth. It's limited by the speed of light and the age of the universe. Light from regions more than about 46 billion light-years away hasn't had time to reach us yet. But the whole universe, the entire space that exists, could be much larger than what we can observe. It might extend far beyond our horizon. It might even be infinite, stretching endlessly in all directions. We have no direct way to study these distant regions, but we can make educated guesses based on what we see nearby. Scientists assume that the laws of physics work the same way everywhere. This principle, called the cosmological principle, suggests that the universe is roughly uniform on large scales. The part we can see should be representative of the whole. If our visible region is flat and contains a certain density of matter, then distant regions probably do too. This assumption seems reasonable and has been confirmed wherever we can test it, but it remains an assumption. Perhaps in regions far beyond our view, conditions are different. Perhaps space curves in ways we can't detect from here. Perhaps our observable universe is just one small patch in a much more varied cosmos. These possibilities remain open, adding to the mystery of whether space ends and what lies beyond what we can see. Now let's think about the concept of infinity itself. It's a strange idea, one that human minds struggle to fully grasp. Infinite means never-ending, going on forever, always having more beyond whatever point you've reached. It's not just very large, it's larger than any number you could name, larger than any distance you could measure. Mathematics deals comfortably with infinity. Mathematicians can work with infinite sets, infinite series, infinite spaces. They have rigorous ways of thinking about different types of infinity, some larger than others, in specific mathematical senses. But experiencing infinity, actually encountering something truly without end, is beyond our direct experience. When we contemplate an infinite universe, we're imagining something we can never fully grasp. We can think about it, reason about it, work with it mathematically, but we can never see it all, never hold it complete in our minds. There's something humbling about this, and also something liberating. The universe might be bigger than we can fully comprehend, and that's okay. Mystery can be peaceful. A finite universe is easier to picture in some ways. We can imagine space with a definite volume, even if that volume is incomprehensibly large. We can think about traveling all the way around it, even if the journey would take longer than the current age of the universe. There's something comforting about finitude, about the idea of a complete, bounded whole. But both possibilities, infinite and finite, lead to similar feelings of awe. Whether space goes on forever or curves back on itself, either way, it's vast beyond everyday comprehension. Either way, it contains wonders beyond counting. Either way, it provides a stage for the cosmic drama of galaxies and stars, planets, and possibly life, to unfold over billions of years. Let's explore the mathematics of cosmic topology a bit more gently. Imagine taking a rectangular piece of paper and connecting opposite edges. If you connect top to bottom, you get a cylinder. If you then connect left to right, wrapping the cylinder around itself, you get a torus, that donut shape we mentioned earlier. This torus is flat, meaning its local geometry follows the rules of ordinary Euclidean geometry. Yet it's finite in extent. This same idea works in 3 dimensions, though it's harder to visualize. Imagine a 3-dimensional box where opposite faces are connected. Anything leaving through one face immediately enters through the opposite face. This creates a space that's flat yet finite, with no boundaries. You could fly your spaceship in any direction forever and never hit a wall, but you would eventually return to your starting point. There are actually many ways to connect the faces of such a box, creating different topologies. You could add twists or reflections to the connections. Each variation creates a different 3-dimensional shape with different properties. Mathematicians have classified all the possible flat, finite, 3-dimensional spaces. There are exactly 10 of them, called the Bieberbach manifolds, after the mathematician who first described them. Any of these could be the topology of our universe if space is flat and finite. To distinguish between them, we would need to see patterns in how galaxies or cosmic microwave background fluctuations appear across the sky. Some shapes would create specific symmetries or repeated patterns. Others would show different characteristic signatures. So far, observations haven't revealed any of these patterns, suggesting either that space is simply infinite or that it's finite, but with a topology so large we can't detect its effects yet. There are also curved versions of these topologies for closed or open universes. A closed universe could have the topology of a sphere, but it could also have more complex shapes. The Poincare dodecahedral space is one example, where space curves into the shape of a 12-sided polyhedron with its faces appropriately connected. This would create a finite universe with a specific, relatively small volume compared to a simple spherical space. Some scientists have looked for evidence of such exotic topologies in the cosmic microwave background. They search for matching circular patterns that would indicate we're seeing the same patch of the early universe from 2 different directions. So far, no convincing matches have been found, but the search continues. It's a beautiful quest, looking for signs that space wraps around itself in hidden ways. Let's think about what life would be like in a universe with complex topology. Imagine living in a cosmic hall of mirrors, where you could look in certain directions and see your own galaxy from the back. Astronomers would detect what appears to be many galaxies, but some of them would actually be the same galaxy viewed from different angles through space's connected paths. This would create confusion at first, but eventually patterns would emerge. Scientists would notice that certain galaxies appear in multiple locations with the same structure and properties. They would map out the topology, understanding how space connects to itself. They might even be able to determine the exact size and shape of the universe by studying these repeated images. In such a universe, the concept of distance would become interestingly ambiguous. There might be multiple paths between any 2 points, some shorter than one, others. The shortest path between you and a distant star might not be a straight line, but a path that takes advantage of the topology's connections. Space navigation would require understanding not just geometry, but also topology, knowing which apparent direction actually leads where. These ideas might seem abstract, but they're grounded in solid mathematics and physics. They represent real possibilities for how space could be structured, and they remind us that the universe might be far stranger and more interesting than our everyday intuitions suggest. Now, let's return to that peaceful feeling of not knowing. We've explored many possibilities for whether space ends, considered the evidence, examined different scenarios, and we've arrived at a simple truth: we don't know for certain. Science has narrowed the possibilities, given us a framework for thinking about the question, but the ultimate answer remains uncertain. This uncertainty is not a failure, it's an invitation. It invites us to keep looking, keep measuring, keep thinking. It invites wonder and curiosity. It keeps the universe interesting, mysterious, full of discoveries waiting to be made. If we knew everything already, if all questions were answered, something precious would be lost. So, as we prepare to let these thoughts drift away into sleep, let's embrace that uncertainty. Let's find peace in not knowing, comfort in the mystery. The universe doesn't require our understanding to exist. It continues regardless of whether we can map its boundaries or prove its infinitude. And that's as it should be. Reality is bigger than our knowledge, and that's a beautiful thing. Think about how far humanity has come in understanding the cosmos. A few centuries ago, we didn't know that other galaxies existed. We thought the Milky Way was the entire universe. Now, we know there are roughly 2 trillion galaxies in our observable universe alone, each containing hundreds of billions of stars. We've measured the age of the universe, mapped the cosmic microwave background, detected gravitational waves from colliding black holes, and found thousands of planets orbiting other stars. We've built instruments that can see across billions of light years and back billions of years in time. We've developed theories that describe the behavior of space and time themselves. Yet, with all this knowledge, we still can't say for certain whether space ends. The question remains tantalizingly open. Perhaps future observations will settle it. Perhaps new theories will emerge that make testable predictions about the universe's extent. Or perhaps the question will remain forever at the edge of what we can know, a boundary we can approach but never quite cross. Let's imagine that future for a moment. Imagine telescopes far more powerful than any we have today, able to map the cosmic microwave background with unprecedented precision. Imagine computer simulations that can model the entire observable universe in detail, testing different topologies against observations. Imagine new physics that provides insights into how space itself behaves at the largest scales. These advances might give us answers, They might reveal that space is infinite, or they might discover telltale signs that it curves back on itself at some vast distance. They might detect patterns that indicate a complex topology, or they might confirm that space is simply infinitely flat. Whatever they find, it will be another step in humanity's long journey of understanding. But even if we never get a definitive answer, the journey itself is worthwhile. The act of asking the question, pursuing it with instruments and mathematics and imagination, expands our horizons. It teaches us about how nature works, about the structure of reality, about our place in the grand scheme of things. The question enriches us, even without a clear answer. Consider the people who will pursue these questions in the future. Young students today might grow up to be the astronomers who finally determine the universe's topology. Children not yet born might develop new theories or build new instruments that solve the mystery. The quest continues across generations, each adding their contribution to the collective human effort to understand. And through it all, the universe remains patient, holding its secrets lightly, revealing them slowly. It doesn't rush to explain itself. It doesn't push answers on us. It simply exists, vast and mysterious, and allows us to explore at our own pace, making discoveries when we're ready, remaining mysterious when we're not. This patience of the cosmos is worth emulating as you prepare for sleep. Don't rush toward answers. Don't force understanding. Just be present with the questions. Let them swirl gently in your mind, and then release them as sleep approaches. The universe has waited billions of years. It can wait another day for you to think about it again. Your mind has wandered through so much tonight. Flat universes and curved ones, infinite expanses and finite spaces, observable horizons and cosmic topologies, dark matter and dark energy, the Big Bang and the far future. These are grand thoughts, beautiful in their scope, peaceful in their abstraction. Now let those grand thoughts become smaller, softer, less defined. Let them blur into general feelings rather than specific concepts. A sense of vastness, a gentle wondering, a peaceful acknowledgement that the universe is bigger than understanding, older than knowledge, more mysterious than any answer we might find. Feel your body becoming heavier, more relaxed. Feel the boundary between waking and sleeping becoming softer, less distinct. You're approaching your own horizon now, the edge where consciousness fades into dreams. This is a good boundary, a gentle one, an ending that leads to renewal. Does space end? Perhaps. Perhaps not. Right now, it doesn't matter. Right now, there is only this moment of letting go, this surrender to sleep's embrace. The universe will take care of itself. Your task is simply to rest. And so, with a final gentle thought about the cosmos and its mysteries, let yourself drift completely now. Let sleep come in its own time, in its own way. Let the questions float away like leaves on a slow stream, returning eventually, but not now, not tonight. Tonight is for rest, for dreams, for the simple peace of being alive in a universe that might be infinite, or might curve back on itself somewhere beyond the stars. Either way, it's beautiful. Either way, it's home. Either way, it's exactly what it needs to be. And so are you. You've thought enough, wondered enough, contemplated enough. Now it's time to sleep, to let the universe spin on without your attention, to trust that everything will still be here when you wake. The stars will keep shining. Space will keep expanding. Galaxies will keep spinning through the darkness. And all of it, every bit of the vast or infinite cosmos, will continue its ancient dance while you rest, while you dream, while you simply exist in this small, precious moment of your life. Let's spend a few more gentle moments thinking about how this question of space's ending touches other aspects of our existence. When ancient peoples looked up at the night sky, they saw a dome of stars overhead. They imagined the heavens as a ceiling, a boundary beyond which lay something else, perhaps the realm of gods or spirits. The sky was an ending, a limit to the physical world. This view was comforting in its way. It made the cosmos comprehensible, contained, with clear boundaries between the earthly and the celestial. The universe had a structure that made sense within human experience. Everything had its place, from the earth at the center to the stars at the edge. Then, gradually, this picture changed. Astronomers discovered that Earth orbits the Sun, not the reverse. They found that stars are distant suns, not lights embedded in a celestial sphere. They realized that the Milky Way is a vast collection of stars, and that other galaxies exist beyond it. With each discovery, the universe grew larger, and its boundaries, if they existed, moved farther away. This expansion of our understanding could have been frightening. Each step revealed that we were not at the center, that the cosmos was far vaster than imagined, that our place in it was smaller than we thought. But instead of fear, many people felt wonder. The universe became more interesting as it grew larger, more filled with possibilities, more worthy of awe and contemplation. Today, we face a similar moment. The universe might be infinite, extending beyond all imagination. Or it might be finite, but so large that it might as well be infinite for any practical purpose. Either way, we find ourselves in a cosmos whose scale defies complete comprehension. And once again, we can choose wonder over fear, curiosity over anxiety. Think about what it means to live in a time when we can seriously contemplate whether space ends. We have the mathematics to describe different geometries, the physics to understand how space curves and expands, the instruments to measure the shape of the universe itself. Our ancestors could only guess at such things. We can calculate, observe, test. This ability is a gift, a product of centuries of human curiosity and effort. Every generation has added to our understanding, building on what came before, reaching a little farther, seeing a little clearer. And the quest continues, not because we must know, but because we can't help wondering. Curiosity is part of what makes us human. As you lie here, preparing to sleep, you're participating in this ancient human tradition of wondering about the cosmos. You're asking the same fundamental questions that people have asked for thousands of years, even if the language and concepts have changed. Does the universe have limits? What lies beyond what we can see? Are we alone in all this vastness? These questions connect you to countless others across time and space who have looked up at the night sky and wondered. You're part of a vast conversation that spans generations, a collective human effort to understand our place in the grand scheme of things. That's a beautiful way to think about it as sleep approaches. Consider also how this question relates to other boundaries in your life. We all have horizons, limits to what we can see and know. We can't see the future or fully understand other people's inner experiences. We can't be in two places at once or know everything about even the tiniest corner of reality. Boundaries are part of existence. But like the universe's potential boundaries, our personal boundaries aren't walls. They're not barriers that imprison us. They're simply the current limits of our perception and understanding. And like our observable horizon in space, our personal horizons can expand. We can learn new things, have new experiences, grow in understanding. The boundaries move outward as we move forward. There's something deeply peaceful about accepting these limits while remaining curious about what lies beyond them. You don't need to know everything to be at peace. You don't need to see beyond every horizon to appreciate the view from here. Certainty isn't necessary for contentment. The universe models this for us. It exists perfectly well whether space is infinite or finite, whether we understand it completely or remain forever puzzled. It doesn't require our comprehension to function. The planets orbit, the stars burn, the galaxies spin, all without needing us to figure it all out. There's a lesson in that, an invitation to relax our grip on needing to know. As your breathing deepens and sleep draws nearer, let this lesson sink in. You can wonder without needing answers. You can contemplate mysteries without solving them. You can appreciate beauty without understanding its source. The universe has given you permission to not know everything, to be comfortable with uncertainty, to find peace in the space between questions and answers. Think about the photons of light traveling through space right now, journeying from distant galaxies toward Earth. Some will arrive while you sleep. Others will arrive long after you've woken. A few might arrive years or decades from now, carrying information about the cosmos as it was billions of years ago. These travelers through space don't worry about whether space ends. They simply move at the speed they move, covering the distance they cover, bringing information whenever they arrive. You can be like those photons in your own way, moving through your life at your own pace, covering the distance you can cover, bringing your own light to the world, small as it might seem, against the vast backdrop of the cosmos. You don't need to reach the edge of everything to matter. You don't need to understand infinity to be infinite in your own small way. Every person contains multitudes, as a poet once wrote. Your mind holds memories, dreams, hopes, fears, ideas. You're a universe of consciousness, however small or large consciousness might be. And like the larger universe, the inner universe of your mind has its own mysteries, its own questions without clear answers, its own horizons beyond which lie unknown territories. Does consciousness end when the brain stops? Does it extend in ways we don't yet understand? Questions about the inner universe parallel questions about the outer one. Both involve boundaries and extent, endings and continuations, finite and infinite possibilities. Both invite wonder and resist simple answers. But right now, your consciousness is gently fading towards sleep. That ending is not frightening. It's natural, restful, necessary. You end your waking day and begin your dreaming night. Tomorrow you'll wake and begin again. This cycle of ending and beginning happens every day, a small echo of larger cosmic patterns of creation and transformation. Imagine the universe breathing, expanding like an inhale, perhaps one day contracting like an exhale, though current evidence suggests otherwise. Or perhaps simply continuing to expand forever, like an infinitely long, slow breath outward. Either way, there's a rhythm to it, a pattern of change that feels almost alive. You breathe too, in and out, a rhythm that sustains your life. Right now, your breathing is slowing, becoming more regular, more peaceful. Each breath takes you deeper into relaxation, closer to sleep. You're synchronized with the universe in this tiny way, both of you in motion, both of you following natural patterns, both of you exactly as you should be. The question of whether space ends is really a question about limits and possibilities. It asks whether the universe has a final boundary or whether it offers unlimited extent. And this question, at its heart, is about hope and wonder. An infinite universe suggests infinite possibilities. A finite universe suggests completeness and wholeness. Both are hopeful in their own ways. As you drift into sleep, carry that hope with you. Whether space ends or continues forever, whether you ever learn the answer or remain forever wondering, the universe is a place of beauty and mystery. You're fortunate to exist in such a time and place, able to even contemplate these questions, able to appreciate the vast or infinite expanse above and around you. Let your final waking thoughts be simple and peaceful. The universe is large. Space is real. You are here. And for tonight, that's everything you need to know. The rest can wait for tomorrow, or next week, or next year, or forever. Right now, there's only the gentle passage from waking to sleeping, from thinking to dreaming, from questions to quiet rest. Feel how natural this transition is, how easy it becomes when you stop resisting, how peaceful it feels to let go of needing to understand. Your mind has traveled far tonight, across billions of light years in thought, through geometric concepts and cosmic histories. Now, it's time for your mind to rest, to simply be without trying to comprehend. The universe will keep its mysteries. Space will maintain its secrets about endings and infinities. And you will sleep, peacefully and deeply, restored by rest, ready eventually to wonder again. But not now. Now is for letting go, for surrendering to the natural need for sleep, for allowing consciousness to fade into the gentle darkness that precedes dreams. You are safe here. The universe is vast, but you are in your own small corner of it, comfortable and protected. Whether space ends somewhere beyond the stars or extends forever, doesn't change this moment of security and rest. You're held gently by gravity on the surface of your planet, surrounded by atmosphere, wrapped in warmth. All the cosmic vastness is out there, and you are here. And that distinction is comforting. Close your eyes if they're still open. Let your body become completely still, completely relaxed. Feel the weight of the universe pressing gently down through gravity, holding you safe against the earth. Feel the rotation of the planet beneath you, carrying you through space at thousands of miles per hour, so smoothly you don't feel it at all. Feel the motion and the stillness coexisting, just as you coexist with the vast cosmos, both separate from it and part of it simultaneously. This is the paradox and the peace of existence. You are infinitesimally small in the cosmic scale, yet you are here, conscious, able to contemplate the whole. You are temporary, brief against the age of the universe. Yet in this moment, you exist as fully as anything has ever existed. You are limited, bounded by your body and mind, yet your thoughts can reach to the edges of everything, wherever and whatever those edges might be. Embrace this paradox as you fall asleep. Be both small and significant. Be both temporary and eternal in this present moment. Be both limited and unbounded in your capacity for wonder. The universe contains multitudes, and so do you. And in the end, that's more important than knowing whether space has an end. Good night now, truly and finally. Release all these thoughts into the darkness. Let them fade like stars at dawn, still there but no longer visible, no longer demanding attention. The cosmos will continue without your observation tonight. Your mind can rest from its wandering. Your body can sink completely into sleep. May your dreams be as peaceful as the quiet space between distant stars, as gentle as light traveling through the darkness, as restful as the universe itself at the moment of its birth. You have earned this rest. You have wondered enough. Now, sleep deeply, sleep peacefully, and let the infinite or finite, or whatever it might be, universe, cradle you softly through this night and every night to come. Sleep now, let go, rest well.